Okay, so today we're going to go over really quickly limit properties. And then we're going to do some solving limits algebraically. So make sure that you get um, the topic in your notebook. That's the topic for today. And then, yeah, let's get started. So, limit properties. These are just things that you are supposed to know. We did this in pre-calc in the spring. Um, Technically, you're supposed to know them by heart. We will get more practice with them over time. But basically, like you can split up, like if you're taking the limit of two functions being divided, you can split those into the limit of the top over the limit of the bottom. Stuff like that. It's just rules. The limit of two functions being multiplied, you can split that into the limit of like one function multiplied by the limit of the other function. So things like that. So we're going to really quick do some practice problems with these. So write this first example down so that you know how to do it. The first one is find the limit if the limit as x approaches c of f of x equals 3, the limit as x approaches c of g of x equals -2, and the limit as x approaches c of h of x equals 4. Okay, so limit as x approaches c, this is what we're trying to find. The limit as x approaches c of h of x times f of x plus 6. All right, so by using limit properties, we can say that this limit is equal to the limit as x approaches c of h of x times, and then we could say the limit as x approaches c of f of x plus 6. All right, and then if we want to break that down even further using our properties, we would say that's equal to, actually, let's simplify really quick. What is the limit as x approaches c of h of x? So they gave us limit as x approaches c of h of x is 4. So like this thing turns into 4. So 4 times, and then we can kind of like think of it as distributing this limit in, but it's times the limit as x approaches c of f of x plus the limit as x approaches c of 6. Okay, so now let's simplify further. They gave us the limit as x approaches c of f of x. That's right here. That's 3. So we have 4 times 3, bring down your plus, okay, this one. This is really important. So we're going to make sure we talk about it. The limit as x approaches c of 6. Okay, the limits are y values, right? This function, 6, this is the function, f of x equals 6. That function looks like this. This is x, y, here's 6. That function looks like this. No matter what x value you're approaching, like say this is x equals c, your limit is always going to be the y value, 6. So the limit of a constant, this is a rule that you need to know, the limit of a constant is just that constant. The limit of any constant is the constant. So this is 3 plus 6. Okay, equals 4 times 3 plus 6 is 9 equals 36. Boom, done with that one. Let's move on. All right, limit as x approaches c of f of x of g of x. If we're using our limit properties, this is the same as the limit as x approaches c of, oh, shoot, sorry. Let me erase. This is the same as f of, using the limit properties above, this is the same as f of limit as x approaches 3 of g of x. Okay, so now we do normal order of operations, do the inside of the parentheses first. So let's take this limit, x approaches 3 of g of x. Here's my g of x function, x equals 3 here. And limit is the y value. If you put yourself on the line on the left and the right, the y value at x equals 3 is 1. So this is 1, this red part. So we have f of, and then we're going to put a 1 in there because that limit is 1. Okay, and then equals, now we're just going to find f of 1. So let's go over to the f graph, go to where x equals 1, and f of 1 is the y value at x equals 1, which is -2. Done. Okay, moving on. So just so y'all know, these are limit properties that you should know. If you're struggling with them in Khan Academy, there's like reminder videos of how to do them and also a lot of practice problems. Okay, let's move on. So when a graph isn't helpful, you can solve limits using algebra. So that's what we're going to work on today. You eventually will learn how to analyze limits by all of these following methods. Direct substitution is going to be something we do today. We're going to learn like a basic limit theorem. We're going to learn the factor cancellation technique today. Eventually, we will know all of these. The substitution theorem is an important theorem, but you know what? I'm going to put it in my own words. So if you want to know it, you can come back and read it. But for today, we're just going to like go with kind of like how I phrase it. Okay, but one thing that we do need to pay attention to right here is this note. Always try direct substitution first. If you get 0 over 0 or infinity over infinity, then we'll need to simplify. But always try direct substitution first. After you simplify, if you get one of these, then you'll try substitution again. Okay, so that's kind of like what we're going over today. We'll do a lot of examples, but we got to move quick. All right, write that down in your notebook. Always try substitution first. Cool. So algebraic methods for solving limits. 1. Substitution. You should definitely be writing this stuff down. So you should write down algebraic methods for solving limits. You should write down substitution. And you should write down the sentence. If your function f of x is continuous. If f of x is continuous, sorry about my handwriting, this pen is kind of awkward, then you can use substitution to find the limit. If f of x is continuous, you can use substitution to find the limit. Okay, really quick, what does continuous mean? Continuous means you have no holes. Write this down. Continuous means you have no holes. Here's an example of a hole when your function looks like this and has a hole. That's the x-axis, y. Okay, you can have no jumps. If your function's continuous, it will not have any jumps. Here's an example of a jump. Your function could look like this. That's x, that's y. And then lastly, for your function to be continuous, there can be no asymptotes. No asymptotes. And here's an example of what a function with an asymptote might look like. Okay, y'all get the picture. X, Y. Cool. So, if we're continuous, we have none of those things. No holes, no jumps, no asymptotes. Now, how are we going to solve limits by substitution? Solving limits by substitution just means plug in. And it works like this. All right, get this example down. The limit as x approaches 3 of x squared. Substitution means plug in. So we're going to plug 3 into x. So the limit as x approaches 3 of x squared is 3 squared equals 9. Done. It's that easy. All right, I'm going to show you one more, and then you're going to do the next two. Limit as x approaches 0 of x plus 1. Limit as x approaches 0 of x plus 1, we're going to plug in the 0 to the x. So that's 0 plus 1 equals 1. Cool. Now, remember, this only works for continuous functions. Really quick, let's talk about how do we know this is continuous? What does x squared look like? That graph looks like this. That's like the curve x squared. Remember in the calc summer homework packet how I said you should know what functions look like, what shape they make? This is why it's important. X squared is continuous. There's no holes, no jumps, no asymptotes. X plus 1, what shape is that graph? Straight line. Looks like this. A line starting at 1. Does it have holes, jumps, or asymptotes? No. So it is continuous. All right. X cubed, really quick, we're going to go over all these, and then you're going to solve these limits. X cubed is continuous. It looks like this. Sin x is continuous. It looks like this. No holes, no jumps, no asymptotes. Okay, so now I want you to solve these two. What do you get for number 3 and number 4 when you solve these limits using substitution? You can use substitution because they're continuous. Okay, so number 3, you should have plugged in the 4 into x. You get 4 cubed, and 4 cubed simplifies to 64. Number 4, you should have plugged pi over 4 into x, and you get sine of pi over 4. You may not remember what that is, but you should know what that is, square root of 2 over 2. I'm going to do a trig review video for y'all, and hopefully it will help if you're still struggling with trigonometry. Okay, let's move on. What about for piecewise functions? This is important. For the piecewise function above, what is the value of limit as x approaches 2 from the left? So remember, this little negative sign means from the left. So get this problem down. If you can't write down this piecewise function fast enough, remember you can always go back in your OneNote. Okay, we're going fast. You got to keep up. Try your best. It's going to prepare you for college. Okay, so we have this piecewise function above. We want to know the left side limit. Okay, so the way that I think about piecewise, and this is going to be really helpful, I think, for y'all, so make sure you pay attention. The way I think about piecewise is, think of these inequality symbols as arrows. This is the arrowhead. This inequality symbol, that's the arrowhead. That's the arrowhead. Which way is this arrowhead pointing? To the left. So if you're looking for the left side limit, you're going to use this piece. This arrowhead is pointing to the right. So if you're looking for the right side limit, you're going to use this bottom piece. This is exactly at x equals 2. That's what the function is at that x value. Okay, so we're trying to find the limit as x approaches 2 from the left. So that's going to be, make sure you do not drop your limits. You have to keep writing, you have to keep writing the limits every time. AP exam, they'll take points off if you don't write your limit every time. It's kind of annoying, but it is what it is. Okay, so that means we have the limit as x approaches 2 of, let's put the left piece in there. So that means we are looking at equals the limit as x approaches 2 of, here's the left piece, x squared minus 4x plus 4. Okay, is a quadratic continuous? Yes, it is, so we can use substitution to solve. We get 2 squared minus 4 times 2 plus 4. And if you fully simplify that, you get 0. All right, that's the limit as x approaches 2 from the left of f of x. Sweet. What about the value of the limit as x approaches 2 of f of x? Remember, this is the general limit, so write that down. And we talked about yesterday, for the general limit to exist, the limit from the left has to exist. Well, good news, we already found the limit from the left. Here's the left limit, and the limit from the right has to exist, and they have to be equal to each other. So now we need to find the limit from the right side of 2 to check what is the general limit. So let's find the limit as x approaches 2 from the right of f of x. And that's going to be the limit as x approaches 2 of the right piece, the right-hand piece, equals limit as x approaches 2. My right-hand piece is x squared minus 4x plus 8. X squared minus 4x plus 8 equals, this is a quadratic, it's continuous, so I can substitute. We get 2 squared minus 4 times 2 plus 8 equals, okay, this gives me 4. So the limit as x approaches 2 from the right of f of x equals 4. That's what we just found. Did you see how I wrote the limit each time? Limit, limit. You have to keep writing limit. Just remember that, because it's going to be important. A lot of people get lazy and like to drop their limit, but the AP graders are really mean, and they're going to make you write limit every time. Okay, really quick. Did we answer the question? We were supposed to find this limit. The limit, limit as x approaches 2 of f of x. Did we find that? No, not yet. But we found the left limit and the right limit. These have to equal each other for the general limit to exist. Does 0 equal 4? 0 does not equal 4. So we would say, since the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x, since that's true, the limit as x approaches 2 does not exist. The general limit does not exist. Okay, let's keep moving. That's not too bad, right? Like, substitution is not too bad, but the thing is, in most cases, you will not be able to use a calculator to solve limits. So how do we solve a limit without a calculator when substitution does not work? For example, let's try substitution on this guy. We have, remember not to drop your limit. Actually, since we're substituting, we can drop your limit. So once you plug in 2, you can drop your limit. 2 minus 2 over 2 squared minus 4. 2 minus 2 is 0 over 4 minus 4, because 2 squared is 4. 0 over 0, that is not okay. So, really quick, write this example down, and then let yourself know that this is called indeterminate form. Indeterminate form. Write that down. When you get 0 over 0 or infinity over infinity, that is called indeterminate form. You need to know that for the AP exam. And that's a big no-no. Remember, you are never allowed to divide by 0 in math. Oops, it says it down here. You are never allowed to divide by 0 in math. In order to remember that, I like to think of it like this. No. N-O. No dividing by 0. If you divide by 0, you get undefined. And then, okay, it's okay to have 0 on top. If you have 0 on top, you just get 0. That's okay. Okay? No. Cool? All right, let's keep going. So what do we do when we can't substitute, when it doesn't work? I will show you. All right, we have this huge theorem. It looks wild. You do not need to write it down. But basically this theorem says, if you have a function g and a function f, and they are exactly identical, they're basically twins, except for at one x value. So at x equals c, these graphs are not twins, right? There's something weird happening on f. But if you have twin functions, except for one x value, the limits of those twin functions are actually going to be the same at that x value. And check it out. What is the limit at x equals c of g? Put yourself on the left. Put yourself on the right. We get to the height of L. The limit is L here. Limit as x approaches c of g of x equals L. What about for this function, f? Put yourself on the line, on the left. Put yourself on the line, on the right. Approach x equals c. Y'all get to the same height. You don't get to touch it, but you still meet at the same height, which is L. So, yes, they have the same limit at that one x value, even though it looks a little weird on f. So, how are we going to use that? How are we going to use that theorem when substitution does not work? Here is the trick. This is what you need to write down. You can write it in your own words. Whenever you have a function where substitution doesn't work because of a hole or another discontinuity, try simplifying. Simplify the function to make it a similar function without a discontinuity. So if we simplify the function f, it'll actually look like g. It won't have a hole, or it won't have a discontinuity. And then try substitution. So simplify, and then do substitution. So here we go. We are going to do this one together. So example, this is the one we just looked at. Let's simplify first. Remember, do not drop your limit. Don't drop your limit. Limit as x approaches 2 of x minus 2 over, if we simplify the denominator, we get x plus 2, x minus 2, because difference of squares. Now we can cross out. Don't drop your limit. We have limit as x approaches 2 of 1 over x plus 2, because when you cross everything out on top, it's just 1. All right, you are allowed to drop your limit once you start to substitute. We did simplify. Check. Fully simplified form is right here. Now we need to substitute. So we go equals, we drop our limit because we're substituting. We get 1 over 2 plus 2 equals 1 over 4. Check it out. We did not get 0 over 0 this time. We didn't get 0 over 0. All right, I want you to try this one. You have a hole. You have a hole. There's a problem or a discontinuity at x equals 2, because if you plug in 2, you'll get 0 in the denominator. So you need to simplify this guy, and then substitute after. All right, you try. Okay, so if we were to simplify this, if you simplify this properly, you did not drop your limit, and you had limit as x approaches 2 of x minus 2, x minus 1 over x minus 2. Then you crossed these out. You didn't drop your limit because you're already a calculus pro, and you just had limit as x approaches 2 of x minus 1. Then you realized it's fully simplified, so I can now go to the second step, which is substitute, and I get 2 minus 1, which equals 1. That is your limit. All right, we're not going to do this last one just for the sake of time. Okay, but you would simplify, and substitute. Simplify by factoring a GCF out. You can cross out some things, and then you would substitute. Cool. Let's move on to practice.